All right, what's going on, everybody? It's Kistner again, and today we are focusing on lesson 2.5, completing the square. It is out of page 50 in your student companion. We're going to skip that opening page again. Um, Completing the square is very, very useful for one, well, really we're going to use it for one thing, this unit. And what that is useful for is going from standard form of a quadratic over to vertex form. Okay, so that's really like going, and equation-wise, that's going from y equals ax squared plus bx plus c over to y equals a times x minus h squared plus k. So that's what that is. And that's how we're going to do it. We do this by completing the square. Now let's first off just kind of get into this. We need to find the solution to this equation, and we're going to use this equation right here. We're going to use square roots to do this. Now that seems kind of weird because in order to take the square root of something, everything has to be squared, and only the x squared is squared here. But let me rewrite this thing. I don't like, for some reason in this situation, everything has the answer on the left. I like the answer on the right. It's just a personal preference. I'm going to rewrite this as x squared plus 12x plus 36 equals 81. I just moved the 81 over. Now, way back in Algebra 1, you learned something that looked like this. If you have a plus b squared, that is the same thing as a plus b times a plus b. And if you FOIL it out, you get a squared plus 2ab plus b squared. Now, we are going to use this and this a lot today. You need to remember that a plus b squared is a squared plus 2ab plus b squared. Or you can look at it like this. There's a minus side of it too. A minus b squared is a squared minus 2ab plus b squared. We need to memorize this because we're going to try to get things into this form, the right-hand form, and then just rewrite them as this left-hand side. So right here, I can't take the square root of the left-hand side because not everything's a perfect square. 12 is not a perfect square. But if you picture this as x squared plus, and I'm going to try to write it as 2ab. So 2 times x times 6 plus 6 squared. So here, you see this is a perfect square, this is a perfect square. If they both end in squares, and that middle term is 2 times this thing, this number you're squaring, you can rewrite it. And we can take the square root of both sides. Now this will factor into, because this is a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. So this is going to be a plus b squared. X plus 6 squared equals 9 squared, or 81. And now we can square root both sides. And we get x plus 6 equals plus or minus the square, plus or minus 3. Sorry, plus or minus 3. And we solve both of those. X plus 6 equals 3, or x plus 6 equals negative 3. And you'll get x equals, sorry, I don't know what I'm doing here. This should be 9 the whole way down. Sorry, got a little distracted there. X equals 9 or negative 9, plus or minus 9. Now we get x equals 3 or x equals negative 15. Okay, we'll do part B. I'll make sure we understand about it, part B, next class. But we're going to try to write this, and I'm going to rewrite it again. X squared minus 6x minus 11 equals 0. I want to write it in x minus p squared equals q form. Now, this is not a squared minus 2ab plus b squared. So we can't just go right into this. But there are two steps to complete the square. First step is to bring the constant to the other side. Bring the constant to the other side. Okay, so in this case, we are going to do what we call completing the square. We are going to do what this whole section's about. Completing the square. So the first step is bring that constant to the other side. So I'm going to add 11 to both sides. So I'm going to be left with x squared minus 6x. Now watch what I do here. I'm going to leave a blank right here. I'm going to leave a blank spot. I'm going to put a plus sign and leave a little blank, and then put equals positive 11. Okay? Now, I want this to be a squared minus 2ab plus b squared. So when we complete the square, if we have x squared minus bx, that's what we have here. Let me change the color on that so it's a little bit easier to see the differences here. Okay. If we want to complete this square, we add b over 2 squared. We cut b in half and we square it. So here we're going to cut the negative 6 in half, which is 6 divided by 2 is 3, so it's negative 3. So we're going to add in a negative 3 squared. Now if I add in a negative 3 squared, let me change the color there. If I add in a negative 3 squared, I have to add it in on the other side as well. Okay, I have to add it in on the other side. So what is negative 3 squared? Well, that's 9. So this is the same thing as 9. So I'm going to add 9 as well. So this becomes x squared minus 6x plus 9. And over here I have 11 plus 9. Because if I do it to one side, I have to do it to the other. Now this is a squared minus 2ab plus b squared. This will always, always, always break down into x minus b over 2 quantity squared. This thing will always go into this. Okay? Let me make one more step back one time. Maybe show this a little bit simpler. If we factored this into two binomials, it would go into x and x, 3 and 3, and both of them would be negative. And this is going to equal 20. So this is x minus 3 squared equals 20. And this is what it wanted us to do. It wanted us to write it at x minus something squared equals 20. So the shortcut is, if you can get it to this, if you can cut b in half and square it, this will always break down into x plus b over 2 squared. Always breaks down into that. So let's look at that and talk about how to solve it. Once again, it's kind of written backwards. So let me write this normal. X squared plus 4x plus 8 equals 0. So like I said, your first step is to bring the 8 to the other side and leave a blank. So x squared plus 4x blank equals negative 8. All right, so I'm going to cut b in half to get 2. I'm going to cut 4 in half to get 2 and square it, which is 4. So remember, this is 2 squared, or b over 2 squared. If I do it to one side, I have to do it to the other, so I'm going to add 4 to this side. Add it to one side, you have to add it to the other. And now we start to simplify. This will always break down into x plus b over 2 squared. So that's what I'm going to put here. X plus 2 squared equals negative 4. Okay. Square root both sides. Square root both sides. So when we square root both sides, we get x plus 2 equals, and let's just break this down a little bit. This is going to be negative 1 times 4. So we get 2i plus or minus 2i. And I want to solve for x. So I'm going to subtract 2 and get that x is equal to negative 2 plus or minus 2i. Square root of negative 1 is I. That's where that came from last section. We will do part B in class together to make sure that we all understand this. Okay. And we'll do example 4 in class together. So I hope you guys are having a good day. I hope you guys are understanding a little bit more. Watch this over. I'll explain it a little bit more in class next time I see everybody. Other than that, make sure you have submitted your last work online. And this is Kistner out.